Hi guys, today I'm gonna walk you through the process of determine the permitted regions for the transfer functions. The permitted region to place the pose in the of the transfer functions based on the step response characteristic like settling time, racing time, overshoot. Okay, let's begin. So eventually you're gonna get a graph something like this, and then this is your the Y regions. Over here is your permitted regions. Okay, let's begin. We're gonna draw it on the um, complex plan. So this in this task I will focus on the stable system where all of your poles gonna be placed on the left hand right side of the plan, because if there's positive real values in your poles, the system gonna be unstable. So we're gonna our permitted region gonna be in this size of the plane. Uh, so to start with, you're gonna be provided with an racing time. In this case, I'm gonna use T rise from 10% to 90%. We have that omega n equal 1.8 over T rise. So in this case, let's say your Tn from 10 to 90% is T rise equal 1. Then your omega n equal 1.8 over 1 equal 1.8. So we're gonna draw a set. We're gonna mark the omega n on our axis. So we have omega n equal 1.8. So if we draw a circle around the origins with a radius of omega n, then you're gonna have a semicircle on this side of the axis. We're gonna find sigma. Sigma equal 4.6 over the settling time. So let's say your the task give you settling time equal let's say your settling time equal 4. So your sigma equal 1.15. You mark your sigma on the axis. So the distance from the imaginary axis to the sigma, this is gonna be sigma. So you mark this line. This is 1.15. And then we need to sketch the phase that created um, by the overshoot time. So it's gonna be the angle alpha from the imaginary axis to this line. Is gonna be alpha. So to find alpha, we have sine alpha. Um, we have alpha equal r sine of the zeta. Zeta here is the damping ratio. It's a damping ratio. The task gonna give us the overshoot time MP. So for example, if they give you MP equals 60%, we can use this graph to identify the values of corresponding sigma. So in this case, if m equals 60%, you choose over here, and then you get the value of zeta is equal 0.5. So your damping ratio is going to be 0.5 if the task gives you MP equal 60%. Okay. So after we get the damping ratios, zeta, so from the graph we have zeta is equal uh, 0.5. From the graph we have zeta, so MP equals 16%, so your zeta equals 0.5, and then your alpha equal arcsin of zeta, which is 0.5, which is equal 30 degree. So your alpha up here is 30 degree. Since the graph have to be symmetric, so you're gonna have another angle phase down here, which is also equal to theta, 30 degrees. Eventually, we end up with the permitted regions. Oh my bad, I shouldn't draw it like so close like this. Never mind, it is what it is. So your permitted regions gonna be identified through this line. This is your permitted regions. Okay, I hope the video is helpful. If you enjoyed the content, please give me a like. Thanks for watching, guys.